Hello, welcome to Getting Started with CodeGen Templates. My name is Liz, and I'm joined by our presenter, Senior Professional Services Consultant and Product Manager, Steve Ives. Steve has worked as a technical consultant and trainer for Synergex since 1997, developing e-commerce applications and helping companies maximize their vertical marketing software applications. Steve has experience with networking, building and managing internet connections, and with security firewall solutions. We are so looking forward to his presentation. So without further ado.
Okay, welcome to this DevPartner 2021 session, the title of which is Getting Started with CodeGen Templates. CodeGen is an open source tool that we've had around for quite a long time now, and it's used by a lot of people for a lot of different purposes. Before we get into what I'm hoping to achieve in this session is to give you a level of confidence with how to go about starting to use CodeGen and write your own templates to develop your own software. Some people are doing that. A lot of people use CodeGen just with templates that we provide for SQL replication or Harmony Core or whatever the solution is. And I'm hoping to try and get people a little bit more confident in writing their own. So we'll be spending time looking at what templates are. Before we get going, let's just talk very briefly about what CodeGen is and what it actually does. It's a software tool that we wrote. It's written in Synergy.net. And the intention of CodeGen is it's a tool that you can use to generate code, as its name suggests. But code really is a very broad term. It can basically be anything that's kind of text-based. So it doesn't have to be language code for DBL. It could be XML. It could be JSON that's generated. It could be HTML. It might be code for another language like C# or Java or TypeScript. So the term code is quite loosely used. It is open source. It's freely available for you to use. It is written in Synergy, so you do have to have a Synergy runtime license available for it to use at the point that you're using it. But typically, obviously, this is a software development tool for Synergy developers, so that really shouldn't be an issue for anybody. If you want to know where to go, the URL's on the screen. github.com/synergex/CodeGen is the home of this product and its repository. Documentation you can find at codegen.synergex.com, and both will point you towards the download site, which is, again, you're downloading releases from the GitHub site. Let's talk very briefly about metadata, because metadata is very important when it comes to CodeGen. The word metadata means data about data. When we're dealing with CodeGen, we really have two types of metadata that we primarily use. The most important form of metadata is a Synergy repository. So pretty much, although it is possible to do some code generation without a repository, you're pretty limited in what you can do. And in almost all cases, a repository is used as the primary source of information. The kind of information we're looking for in your repository is basically your record layouts and file definitions. So it's structures and files in terms of what you can do in the repository. And within structures, we're looking for at least fields and keys usually, and possibly, depending on how your files are defined, perhaps tags, perhaps formats, perhaps relations between those different data structures. If you think joins in a relational database, that's what a relation is. If you don't have a repository, it's minimal effort to get started in creating a repository, but it's one of those things that the more information you put into the repository, the more capabilities you can use within CodeGen. But if you don't have a repository, basically importing record layouts and fields and spending a little bit of time to define keys and files can get you up and running fairly quickly. The other metadata we can use is the Synergy method catalog. So if you've ever used XF Server Plus, you'll know that you define interfaces. Within those interfaces, you define methods, subroutines and functions, and parameters. And very often those parameters refer to repository structures as well. So typically you still need a repository, even if you're generating code based on a method catalog. CodeGen also, as well as using metadata, heavily uses things called template files. So a template file is a text file that basically has some content that defines the basic layout for whatever it is you're trying to generate. And that content is typically a mixture of actual code in whatever syntax you're trying to create. So here we've got some examples of some Synergy OO code. As you can see, we've got a namespace keyword and a public class, end namespace, and various public read-write properties. And interspersed with that, we've got various what we call tokens. Those tokens cause CodeGen to do something specific. For example, you can see the CodeGen file name token at the top. You might be able to guess that that's determining what the output file will be called. Structure name is going to be the name of the repository structure that we're dealing with at this point in time. So generating from this template might generate something like customer.dbl or product.dbl. And some of the tokens, most of them here, get replaced with something, but other kinds of tokens get acted upon. So you can see in the middle of the screen, we have field loop, and then slightly below it, end of field loop. And then there's a public read-write property statement between the two. That's going to basically produce that output for every field in the structure that we're producing. We'll talk more about these concepts as we go forward. What CodeGen does is very simple. It combines information from a template with metadata from the repository and or the method catalog in order to produce some kind of output. CodeGen has lots of different types of tokens, but it also does process specific tokens. So it's not anything that begins with a less than and ending with a greater than. It is, because that obviously is very similar to XML, for example, or HTML. It's looking for specific keywords that it knows about. And there are various types of things. File header tokens, we looked at CodeGen file name as an example, are a special group of tokens that go right at the top of the template, typically to set rules and specify requirements and define the name of the output file. And then we have expansion tokens. Expansion tokens are replaced when the code is generated with some value. So the examples you can see here are fairly obvious: the name of the structure or the name of the field that we're currently dealing with in a field loop. Over and above that, we have expression tokens. Expressions are basically special tokens which allow you to test certain values. So in the example we have on the slide, we have if structure ISAM, some code, and then an end of if syntax. So basically what's going to happen here is that code between the opening and closing tokens is only going to be emitted to the output file if the structure that's being processed right now is associated with an ISAM file, as opposed to a relative file or a text file or a user-defined file. Those are the 4 types of file you can define in the repository. Beyond that, we have loop tokens. We already mentioned briefly on the previous slide field loops. So loop tokens allow you to iterate through some collection of data. Repository, if you think about it, has lots of types of collections of data. We have collections of structures. Within each structure, we have a collection of fields. Within each field, there's a collection of maybe selections that might be available with that field. There might be allowed values for the field. The structure might have a collection of keys and so on. And CodeGen has a loop structure that lets you iterate through those things once you're at that level. And then we have special tokens. An example of a special token is counter one increment. So I'll talk about counter tokens a little bit more, but it basically causes something to happen inside the code generation engine while you're processing the template. In addition, as well as basic expansion tokens, we already mentioned that the one you can see on the first row of the table here, structure name, inserts the name of the structure that's currently being processed. Some of the templates have token variations or case variations. So, for example, the structure name token allows all of the case variations that you can see on the left-hand column there, and the output is basically altered based on, so the output is kind of reflects the case that was used to define the token. This is really to do with words being separated by underscore characters. So in some of these cases in the middle column, you don't see much of a difference. But look at what happens in the third column when it's customer underscore ID becomes either uppercase customer ID, lowercase customer ID. This is what we call mixed case. So it's uppercase first character, then lowercase retaining underscores. This is similar. This is what we call XF case. It's what XF Netlink uses. It's uppercase first character. Everything else is lowercase with an underscore preserved. This is what we call Pascal case, and this is camel case. So depending on how you want the data to be output in your file, with some tokens, you can choose to use one of the variations of the token to make that happen. And each of the documentation points for every token will tell you the variations that are valid for that particular token. We'll talk about the documentation again in a little while. Expression tokens. So we mentioned that expression tokens allow you to test some value. Expressions, there are basically two types of expressions. There are inline and multi-line expression tokens. So for example, you might be able to guess that the if alpha expression is a field loop expression that can be used only in a field loop. And it basically tests the data type of the current field being processed. And the code between the opening and closing tokens will only be emitted for alpha fields, okay? So if you need to do something only for an alpha field or a decimal field or an integer field or a date field, for example, then there are expressions that let you do that. Multi-line expressions, you can see that the opening and closing tokens are on separate lines and have one or more lines of code between them. And it's the same thing. The lines of code will be emitted only if this expression is true. All of the expressions also support if not now as well, so you can flip the logic around. And in the case of multi-line expressions, the template lines that have the opening and closing tokens will be emitted. So you won't get a white space line instead of the token. You'll just get the code between them. Also, as well as supporting if not in front of all expressions now, we also now have an else clause. So if the field has selections, use this code, otherwise use this code. And again, this could be done across multiple lines if you wish. Also, expressions can be nested. So you can have one within another, and so on. Also, in a recent version of CodeGen, in the last 6 months, I forget exactly when, we also added support for complex expressions, which really has changed the world in terms of what you can do in template files without those template files being very, very complex. Basically, this is a great way of avoiding multiple levels of nested expressions, and it does even more. So you can now use an else clause, and in addition to the else clause, you can now have multiple else clauses. So this is like if, else if, else if, else if, else if, which is a great piece of functionality in its own right. But also you can now have complex expressions. So you can do things like if it's alpha, else if it's decimal but not precision, or it's an integer type. So it's a decimal, not an implied decimal or an integer. Otherwise, if it's a decimal and precision, in other words, it's an implied decimal. Otherwise, if it's a date or a time. Otherwise, if it's a Boolean, and so on. So you can really get quite complex in what you are able to achieve with the output from these templates. So bringing all of that information together, fairly briefly, here's an example of a very simple template file. It's not necessarily something particularly useful, but hopefully it's enough to give you the idea of how to get started. So this is an example of a template file. As you can see, we've got our file header token saying the output file name will be whatever name of the structure with Pascal casing with underscores removed if there are any reclen. So this might produce customer reclen. And as you can see, it's producing a DBL mainline program called, again, if our structure is customer reclen. And we're just injecting some code to open a file, use getRFA to get the record length of the file and write it out to the console and close the channel. And we're using CodeGen to basically say, if this is an indexed file, then we'll open for indexed input indexed. Otherwise, if it's relative, we'll open for input relative, and we're using it to inject the name of the physical file. Okay, an example of a CodeGen command line that we might use to use this template is CodeGen -t, and we name the template file that we wish to use. There are mechanisms to specify through environment variables which directory the templates are in and things like that. So there's various ways of setting up the environments. But basically, we're saying use this template in conjunction with this repository structure, and it will produce whatever output it produces based on this CodeGen file name token. Okay, so the output from that template and that CodeGen command might be something like this, where the things in yellow have been injected by CodeGen, and we've produced a program that we can, if we run customer reclen, it will say record length is 500 or whatever the length of the record is for that particular file. What's the point? The point is that once you've written your template to be able to do that for that one structure, You can do that for any structure. So if we've got 1,000 files in our system, which isn't that unusual, and we've got 1,000 repository structures and file definitions that define them all, then we can produce this code for every one of those structures simply by saying something like CodeGen -t file reclen -s asterisk. So produce this output for every structure in my repository, and out come 1,000 source files. Okay. Let's talk about the repository a little bit. When you look at the repository, it has various types of data. So on the main level in the repository, when you look at the modify menu, you have templates, formats, enums, structures, and files. Not in that particular order. I think it starts with structures and files. But those are the main things that you can define in a repository. Within a structure, you can also define formats and aliases, and ultimately those things can be used in a structure to define fields. Fields might have lists of selections. Structures can have tags associated with them and keys and relations. And then you can define files that are the physical data files pointing at structures. Okay, so that's the kind of logical overview of what the repository looks like internally. Several of those things, all of these things in color here, are really all to do with, well, with the partial exception of enums, are really all to do with defining fields. And we really don't care about these individual things when we're looking at code generation. We just care about the resulting field set. An exception there is enums. They can be kind of useful to us in other ways as well. So CodeGen's view of the repository is kind of a subset view. It sees almost everything in the repository, but not down to the templates level and things like that. So this is what the repository looks like as far as CodeGen is concerned. And then what we do is we have a hierarchy of CodeGen loops and expression tokens and evaluation tokens that represent that same structure. So within our template code, we can define an enum loop if we want to iterate through all the enumerations. We can define a structure loop to go through structures. Within a structure loop, we can define a field loop to go through fields. If a field has selections, we can define, I know that's tiny text there, but that says field selection loop. So there's a hierarchy of CodeGen templates, not templates, tokens, expansion tokens, expression tokens, loop tokens, and so on, that match the hierarchy of the repository. And the documentation is also set up the same way. So the documentation goes by structure loops and field loops and file loops and so on. So it's nice and easy to navigate around. So the various loop tokens that you can use when you're in repository mode, that means just generating from a repository structure instead of from a method catalog. The loop tokens allow you to iterate all of those various collections, those hierarchical collections of data. Each of them has an opening and closing tag, and whatever code appears between the opening and closing tag for that type of loop, so in this case a field loop, is basically saying repeat this code between them. That might be a single line of code or it might be 1,000 lines of code. It doesn't matter what it is, but repeat that for every field in the structure. And we've already seen we might use expressions within there to say if alpha and only process alpha fields and so on. So we've got a lot of flexibility. And remember, those loops can but in the same way that expression tokens can be either multi-line or inline, loop tokens can also be multi-line to produce a whole block of code, or inline to produce a single line of code based on, if you wanted to list every field with a comma between them, you could have an inline field loop with field name comma, and it would produce that for you. And also loops may be nested. So field loops can be nested inside structure loops. Key segment loops can be nested inside key loops, but only following that hierarchy. So you can't put a key segment loop within a field loop, for example. It has to be within a key loop. So here's just an example of nesting loops. So and it just shows you, again, this is just really a different way of viewing that hierarchy that we talked about before. So we have the possibility of a structure loop, which says iterate through each of the structures that I'm processing right now. We have field loops. In field loops, we can have selection loops. In key loops, we can have key segment loops. In relation loops, and so on. And depending on where you're at in the hierarchy, if I'm in a field loop, for example, I can use generic tokens, which can be used anywhere, and I can use field loop tokens. If I'm in a field selection loop, I can use generic tokens, field loop tokens, and field selection loop tokens. So I can use the tokens for the place I'm at right now in the hierarchy and anything above me. Okay, but I can't be in a field loop and try and refer to key name, for example, because that's a key loop token. Also, this concept of processing multiple structures at the same time. Normally, if you pass a CodeGen command line which says -s and then has 2 or more structures, generally what CodeGen does is process each of those structures individually and process and produce an output file for each one of those structures. If you want to be able to iterate through the structures in a single output file, then there's a command line option that says -ms. That stands for multiple structures. And now you cause it to process all of them at the same time. So it's just going to do a single pass through your template file, and you get to use structure loop to iterate through the multiple structures that you're processing. You can also combine loops with expression and expansion tokens. So this is just a sort of an example of showing you the hierarchy of what's going on. So in this example, we're iterating through all of the structures that we're processing. So you can see we're naming 3 structures, and at the bottom on the command line, and I've used the -ms option, so we get to use structure loop. And then I'm filtering. I'm saying only produce output if this is for an ISAM file. And then we're outputting information about the file and its keys. So we've got a key loop to iterate through all of the keys, and we output information for each key. Just another example of how you might structure a template file. And when processed with the command line like the one below, this is the kind of output that we're going to produce. Again, it's not something that may be particularly useful. CodeGen, some people use CodeGen for producing documentation of their system, documenting all of the files that are there and all of the keys that those files have and so on. So that's a kind of simple example of what this might be doing. Here's another template example. This one's a little bit more realistic of what you might actually do with CodeGen. So this is producing, as you can see, the name of this template is DBL data model. So you might be able to guess from that this is producing a DBL language data model class. A data model typically in the OO world tends to mean a class that represents a data structure and has a property for each of the fields within the structure. And that's exactly what this will produce. So again, we've got our CodeGen file name determining what the name of the output will be. We're outputting a namespace using the namespace tag. The namespace tag, you have to provide the namespace. So if it's used, you'll notice on the command line I'm using, I've got CodeGen template is this, structure is that, n myapp.models right at the bottom right there. That provides the value for the namespace token. And then we're simply we're producing a class based on the name of the structure. We're iterating through every field in the structure and providing a public read-write property. And again, if we use the CodeGen utility with the command line shown below, then this is basically an example of what we might produce with that template. And again, the text that's shown in yellow is the text that was inserted by the various expansion tokens that we used. The field loop obviously produced 1 line per field, and then the expansion tokens are producing the field name, the data type, the name of the class, the name of the namespace, and ultimately the name of the source file as well. This really is just to make the point that nothing in CodeGen limits you to producing DBL code or Synergy code. So this is an example of a template file, which is basically very similar to the one we just looked at, but the base code in the template is C#, not DBL. So we're basically doing exactly the same thing. We're injecting a namespace. We're injecting the name of the class. We're iterating through the fields in the class. We've got braces instead of begins and ends. And the primary difference here is you'll notice the syntax for the property is not Synergy, is not DBL OO syntax now, it's C# syntax. So public, data type, name, get set methods. And notice also we're using field_CS type. In the previous example, if I quickly go back to it, you'll notice I was using field spec. field spec inserts a DBL spec for the current field, a D5.3, for example, whereas the field CS type token inserts a C# compatible type for that kind of field. So instead of injecting a D5.3, it might insert the word decimal, for example. Again, we use this template in the exact same way with the exact same command line, apart from the name of the template itself. And now the output we're producing is a C# data class, not a Synergy data class. And we do have support for C#, VB, DBL, obviously. We have some SQL-specific syntax, so you can generate things for, right now we support SQL Server, MySQL, and Progress, I believe. I'm not totally sure about the third one, I apologize. And you can also produce TypeScript. We recently added some type knowledge for fields to TypeScript compatible data types as well. As well as loops, there are loop variations on some of the loops, not all. Key loops in particular have a lot of variations, as you can see on the slide here. And there are some variations for some of the other loops. The idea is that rather than a straight key loop just says iterate through every key that's defined on the structure. But then you might want to do different things. So for example, the alternate key loop basically does the same thing, but it omits it ignores the primary key. So it only iterates through the alternate keys. Key loop unique actually doesn't do what you might think. This caught somebody out recently. This iterates through any key that has a unique signature. Okay, but if there are multiple keys that have three alpha fields, for example, then it will only emit the first one, because you're going to get duplicate overlays if you're trying to produce a class with those methods. That's what that one's used for. Primary key says only go through the primary key. Unique key says find the first key that is unique and only process that key. Foreign key loop, partial key loop, and so on. So they do different things and iterate different sets of fields based on the loop variation token that's used. Whenever you're dealing with loops, it's also very useful to have what we call loop utility tokens. And a loop utility token basically injects some information. Loop utility there's both expansion tokens and expression tokens. So you can either insert or test basically the status of the loop. So for example, these top 5 actually insert, but basically what these do is they say insert a comma if there are more items to be processed. Insert a plus if there are more. Insert a semicolon if there are more. Or the word and, or the word or, if there are more items to be processed. If it's the last item, nothing is inserted. Processed inclusive translates to how many items have we currently processed, including the current one. And remaining exclusive says how many items remain to be processed, excluding the current one. Okay, and there's inclusive and exclusive versions of both processed and remaining. Total items tell you how many items are going to be processed in the whole loop. How many fields are there in the structure, for example. And also you can make decisions, logical decisions based on things like that. So you can say if first or if last. Is this the first item in the loop, or is this the last item in the loop? Are there more items to be processed? Are there no more items to be processed? And then you can also use this one, which is kind of natty. And this basically says, if processed inclusive operator n, the example there shows you how you can use it. If processed inclusive is 10, then we want to do something special. So you can use this kind of expression to implement paging. If you wanted to break something every 10 and start a new one, you could use processed exclusive EQ10, then terminate the previous one and start whatever the next one is and carry on. I use that in SQL connection code generation, where if you're doing data binding variables to columns in a table, there's an absolute maximum of 254 columns that you can bind with one statement. So I use this kind of functionality to say, once we get to 254, do the bind and then start a new one, that kind of thing. Also, we have counter tokens. Counter tokens actually have become very, very valuable over time. We use them for all kinds of things. Essentially, they allow you to, CodeGen has two counters built in, counter 1 and counter 2, and you can use them to track whatever you want. So if you want to keep track of how many times you've done something or some special case, or if you just need to count how many of something are there that CodeGen doesn't give you a token that does, you can just set up a little loop that just increments the counter each time around the loop and then look at the value of the counter at the end. So I know it's hard to kind of understand until you really get used to doing this stuff, but counters, they simply let you say, reset the value of counter 1, increment it, decrement it, refer to its value, and test its value. And again, you can do things like if counter 1 greater than or equal to 5, that kind of thing, to allow you to do paging and cut things off at a maximum amount of items and so on. Something else you can do in templates is you can add comments. And, generated code is still code, and code should be documented. Yeah, right. We all do that, right? In fact, really, template code should be double documented. What I mean by that is you can document both the structure of the template itself. So putting comments in the template to explain to somebody who might look at the template what this piece of template code is supposed to do is a great idea. And the special syntax for that is semicolon //. That first green line you can see there is a template comment. Template comments are visible in the template file, but are not output to the output file. So literally, you can have a whole block of documentation within your template file explaining how this piece of template code works or what the intention is, and that's a great practice. But also, when you're writing your template code, try and output language, whatever language it is you're generating. Try and output comments that explain what the generated code does, just as you would, if you're writing a piece of code that other people are going to look at and you want to explain what the intent is or how something works. Then it's equally as it's good practice to build that into code that you're writing. It's also good practice to build that into code that you're generating. Okay, so try and use that. Complex templates, complex expressions and else if has helped dramatically with the ability to really simplify what used to be very, very complex templates. Because before we had that, you'd have to have multiple levels of embedded if statements. Sometimes I've got templates that might have had 6, 7, 8 levels of embedded ifs and elses and so on. And it was very, very difficult to read, and just adding a few comments really made a big difference. So I can't encourage you strongly enough to comment your templates and the generated code. Briefly, there is a third type of metadata that we can use with CodeGen, and that is UI Toolkit window scripts. So for those of you that may be doing or may have UI Toolkit code around there, window scripts generate or are used to define UI, typically, primarily input windows and list windows. And you can use those things as a point of input when you're generating code. It is actually possible, and there are some sample templates that ship with CodeGen that will provide you, that will generate a win form based on a Synergy Toolkit window, or a web form based on a Synergy Toolkit window, for example. That's not really the intent. The intent was never to be able to code generate new UI. But what you certainly can do is code generate perhaps a starting point for a new UI. So you might well be able to generate a piece of HTML that is a very basic HTML form that's based on a previous piece of UI, and then have your web developers apply styling and colorization and fonts and all of that kind of thing. At least it gives you a starting point if it's useful to produce a web form that looks like the old toolkit window. In many cases, you're trying to define something completely different, and it might not be useful. But also bear in mind, you could use it to generate data classes based on not all the fields in the structure, but all the fields that are used in this particular piece of UI. And that might be similar in a new application going forward. All code generation or all the metadata from a toolkit script file does is it identifies what is the structure being used in this window and what is the subset of fields used in the window. and it works the same way Toolkit does. It then goes to the repository to read that structure. It throws away any fields that are not used in the window, and it overlays any metadata from the Windows script over the repository definition. So you can then generate on the combination of properties from the script file and the repository structure with the subset of fields defined in the Toolkit window. It's very rarely used, but it is there, so I thought I'd mention it briefly. The second piece of major metadata that we can use with CodeGen was added, I'm going to say about a year ago now, and it primarily for Harmony Core, but it is useful in other scenarios, and that is reading the method catalog that defines an XF Server Plus environment. And we in Harmony Core, we can now code generate web service endpoints that serve up all of the methods that are exposed through XF Server Plus, so that you can call those methods through RESTful APIs, through HTTP, rather than having to use xfnetlink.net or Java or Synergy or COM or whatever it is. So that's what this basic capability allows you to do. Method catalogs have interfaces, have methods, and have parameters. And in turn, those parameters sometimes refer to repository structures. So basically, this support, you identify the method catalog export XML file instead of a repository structure as your data on the CodeGen command line, and that gives you access to interface loops, method loops, parameter loops, and the structures that are associated with any parameters if there are record-based parameters in those routines. So it's just an alternate way of defining template code based on code, not data definitions. Other things that it's useful to know about, CodeGen has the concept of user-defined tokens. So this is a way of you being able to use custom tokens that you decide what the name is. These are basically replacement tokens or expansion tokens. So you can define your own expansion tokens and provide your own value. So if you set up a user-defined token called Fred, or in this example, we're using support email. So if you specify a user-defined token of support email, that can either be done in an XML file called with a TKN file extension, and you just have open token value closed token in that file, or you can specify them on the command line. So -UT says user token support email equals and the value, and you can have any number of UT commands on the command line. Either way, in your template file, you can do two things now. You can say requires user token and name it in the file header area right at the top. That will basically cause CodeGen to fail if the user token is not provided. And then you can refer to its value with this kind of syntax, and that will insert that value at code generation time. Conditional processing is another thing you can do. This has been around quite a while now. The use case of this is to allow you to create templates that do different things based on runtime settable environment. So the example here is where we're defining a value called attach IO hooks. And then within our template, we can test using if defined underscore, and then the name of one of those defines, and again with an end if, and these things can be inline if you wish. Basically what will happen here is this piece of template code will only be processed if that value has been defined on the command line. Okay, so you can have, if I don't define this, then this new IO hooks command will not be output to the output file. So I can tweak things based on setting up the environment externally and have multi-use templates. Customizing CodeGen. First of all, CodeGen is open source, so you're welcome to download the source code. The URL was at the beginning of this session, but basically it's on GitHub/Synergex/CodeGen. You're welcome to download the source code. It is Synergy.net, so you will need a Windows Synergy license and Visual Studio to build it, if you wish. There's really not a lot of point. Every time we do a release, we build a binary distribution with a full Windows installer MSI file that you can provide, and pretty much everybody just downloads the MSI file and installs it. The other thing is it is also runtime customizable. So even if you download our installer and install it, you can create your own extensions in a .NET assembly. And there is a whole chapter in the documentation that shows you how to do this. There is an example of this in the source code solution. So you can create your own extension that has little classes in there that implement new field loop tokens or field loop expressions or key loop tokens or whatever. You can implement pretty much anything I can, you can also do. So if you need to invent your own token that when it's encountered, it injects something specific into the code, or your own expression tokens that test something really complex, or even test something external in your environment, then you can implement your own. It's pretty trivial to do that, and there's a full example in code and it's documented. But before you're tempted to do that, let us know what it is you want to do, because if you want to do it, there's a good chance that somebody else may want to do it as well, unless it's something that's completely custom to your application. So do let us know if you have these kind of requirements or you think of something that would be nice to do. And if it's something that we agree that would be useful to others, we'll do it for you. In terms of how to get started, I recommend you look at the documentation. It's pretty extensive. The first section of the documentation gives you a basic walkthrough and explains some of the things I've covered in this module. So it talks to you about what a template file is and what a token is and what an expansion token is. And it walks you through the whole concept. There's information in there about how to set up your repository and the things you might want to think about when doing so. I spent a lot of time on the documentation, trying to make it as useful as possible. You have two options. When you install CodeGen from our installer, you will be provided with a Windows help file. You can access that either through a start menu icon. So in the start menu, there'll be a CodeGen folder with documentation in there. Or you can do it from the command line. If you type CodeGen space -docs, it will display the Windows documentation for you. Or you can just pick up a browser and go to codegen.synergex.com, and that will give you basically an HTML version of the documentation. It's got exactly the same structure and content. The difference is this will be for the Windows documentation will be for the version you've got installed, whereas the web documentation is always for the very latest version. So I do publish that as part of the release process, and it, like I say, it will update immediately to the latest version every time we do a release, which is usually about once a month. Learning from existing templates, probably the biggest tip I could give you in terms of how to actually get started with this stuff is spend some time and look at some existing tokens. So read some existing tokens, try to understand what the template code does. Try to visualize a repository structure with keys and so on. And as you see key loops and field loops and method loops, try and visualize what that's actually producing. Where to find templates to look at, there's a couple of good sources. First of all, we ship a whole directory full of example templates. I'll be honest, they are kind of dated at this point in time, but they're pretty much still valid. You will find them in the public documents CodeGen templates folder on your system, unless you can switch that off during install, but by default they're there. So go look in public documents CodeGen templates. There is also a utility that, again, is linked in the start menu called the template browser utility. It's a little Windows application that if you run it up, it will give you a list of all the templates that are there on the left, and you click on one and it displays it to the right-hand side. So that's a good way of just browsing through the sample templates. Beyond that, I would point you to a couple of our open source projects, SQL Replication and Harmony Core, because both of these drive Harmony Core in particular drives what we're doing with CodeGen most of the time. It's really pushing the boundaries in a lot of areas, and also SQL replication to a certain extent. If you click on, or you'll be able to type them in, these URLs that you're seeing on the screen, it will take you directly to, in this case, there's just a couple of templates for the SQL project. Harmony Core, that templates folder, has probably 20 templates in there, and then there's 4 or 5 subfolders which all have various templates in as well. So there's a lot of examples available from Harmony Core, and I recommend you just go and take some time and look through some of those. They're all documented. They've got descriptions at the top of what they produce, so you should be able to get an idea of, oh, this produces a data class, or this produces a web API controller or an OData controller, or whatever it might be. Okay, if you do have questions or problems, CodeGen is not something that's officially supported through our DevPartner support department, but it is something we are heavily invested in maintaining and helping you use and fixing any problems you might have. We've been doing this for, I'm going to say, over 10 years at this point. So this is not something that's a fad that's going to go away. But like I say, don't go through the regular support channels. If you have a question or an issue, just go and hit up github.com, Synergex CodeGen/issues, or just go to the homepage and click on the issues tab and just record an issue there. If you've got a question, how do I go about doing something, or you've got a problem, if you've got a problem, try and include maybe the template that you're trying to use, maybe even the repository structure you're trying to use. Give us the stack trace if it's causing an error, that kind of thing. But feel free to post stuff there. Several of us will receive those messages, and we will get back to you as quickly as we possibly can. What can you do with CodeGen? Well, you can't. It's very difficult to define because you can do an awful lot of things with it. If you look at a Harmony Core solution, for example, I'm going to say that in most final Harmony Core products, probably upward of 98% of the code that makes up that entire service. In terms of the code that's there's obviously a lot of code in the Harmony Core libraries themselves, but in terms of the synergy code that makes up the service, probably 98% of it comes straight out of CodeGen. That includes all kinds of data-centric stuff and code-centric stuff and repository-based stuff and method catalog-based stuff, data classes, controllers, business logic, all kinds of different things. And the SQL replication example as well is a good example of producing traditional synergy code, just subroutines and functions that use the SQL connection API to talk to a relational database. So, there are lots and lots of things. Can you generate anything you want? No. But if it's something where you can define a rule and say, this is the general rule, and now I want to do it for that structure, that structure, that structure, or this is the general code, and I want to do it for this method, this method, this method, then there's a good chance you can automate the process with CodeGen. It is one of those things where there is a little bit of a learning curve, but once you get past that initial learning curve and the light goes on and you understand how this thing fits together, then the sky's the limit and you can achieve a lot. And hopefully this presentation will help with that. Repository really is the key. Without a repository, you can do a little bit of code generation, but not much. But getting your repository into great shape is really the key to success with this stuff. Final slide, just to go through some future plans. We are constantly working on CodeGen. We do currently have some things that we intend to do. We very recently extended and added support or better support for group processing. Previously, when a group was encountered in a structure, it literally just flattened out that group into multiple fields. And even if it was nested groups, it would just flatten the whole thing out into multiple fields, prefixing the name of the group fields with the name of the group and so on. And that was causing a few problems in different areas. Names were getting too long for deeply nested sets of groups and so on. So we've recently added support for actually generating and diving down into groups and sort of iterating through the fields in a group and then diving down another level and continuing to iterate and so on in a field loop. But it's fairly basic support. We do have more work to do in that area. We've also, we'll be adding support for some .NET 6 specific features as we go through and do our .NET 6 extensions for the language of the Synergy. We're learning about new things like, for example, .NET 6 finally has data types that allow you to represent date only and time only and things like that. So we'll have some work to do to keep up with those latest things. I am going to be doing some performance testing or performance tuning in the upcoming months. I am aware that when you use code generation with very large numbers of structures, into the multiple hundreds or potentially approaching 1,000 structures, things can take a while. You generate a class for a single structure, it takes milliseconds. But when you're generating from 30 or 40 templates for 1,000 structures, things can start to take a little longer. So we're going to see what we can do to improve that. We've already made some improvements. Also, when we're dealing with method catalog processing, the method catalog XML file is getting parsed more often than we need to right now. So we'll be trying to do some some tuning in that area. And finally, if you watched my product announcement or product update session earlier in this event, you'll know that Synergy.net is going to be supported on Linux platforms, or .NET Core, specifically .NET 6, when we announce support for that. We're going to be moving very soon to supporting that environment on Linux as well as Windows. So at that time, we absolutely will do a CodeGen release so that CodeGen can be used directly on Linux. Right now, it's only a Windows product. It's a .NET framework build right now. And if you're developing for Linux or Unix or OpenVMS, then you have to generate your code on Windows and then take that code to those platforms. So that's in the plan as well. That's all I have. I hope this was useful and gives you some confidence to start dabbling with CodeGen. Let us know if you need any assistance. And with that, I would like to invite any questions.
So now we do have some questions here. From Gordon Richardson, is there a summary document that comes with the templates?
There is not, Gordon. We did used to have a chapter in the documentation that talked about what the sample templates were and what they did, but it got to be a bit of a chore to maintain it. And also a lot of them, as I mentioned earlier, are quite old now. Gordon, I noticed the question from Gordon saying when he looks at some of those old templates, they are harder to read because they don't have the use of complex expressions and else and all of that kind of stuff. And he's absolutely right. But each of those templates, as I mentioned, does have a sort of documentation header section. There's a few lines at the top of each that basically says what this template is. And, based on the name of the template and that brief description, you can browse through them fairly easily and get an idea of what they do. But I do take that feedback, and I take Gordon's feedback in the next question as well. And I will try and maybe find a little bit of time to do some work and improve some of those templates. Excuse me. But equally, this is an open source thing. If anybody wants to get involved in helping to do that, you are more than welcome. If somebody wants to contribute by helping us work on those templates and bring things up to date, or provide new examples of things, then more than happy to have those kind of volunteers to work with. So give us a shout.
Excellent. And here's one question from Gary. Does it support custom code insertion alongside regeneration of the template that keeps the custom code?
You could, well, that's always one of the difficult things, isn't it? When you're generating code in such a way that you can, the ideal is that you can generate the code in such a way that you don't need to modify it. If you do need to modify it, there are a couple of techniques you can use. Depends what kind of code you're generating. Using .includes is one way potentially of getting custom code into there. So you at a certain place in a template and in the output file, you insert a .include or whatever the equivalent is in whatever language you're using to pull code in at build time, but without actually editing the actual generated code. That's often possible. If you are generating more modern code, which a lot of people are now generating, methods in classes in namespaces, then there's several techniques that you can use to deal with custom code. And again, if you look at the Harmony Core code base, we do this fairly heavily in Harmony Core. We try and put extensibility points on everything we possibly can. And there are two core techniques that we use to do that. One is partial classes, so that you can always extend the functionality or provide additional things. If you, for example, want to code generate a Harmony Core OData endpoint for a structure, but you also want to enhance it with additional custom endpoints over and above the CRUD stuff that it creates for you, then you can add a partial class and add your own endpoint methods in there and go crazy. It's great. Also, related to the use of partial classes, something that some people aren't that familiar with is we have support for, and have for quite a while, for partial methods. I know that's a little strange concept to someone, but a partial method is something that you can, as a developer, optionally implement following a following a certain design or a certain interface. So you can implement a method in a partial class that we will call for you if it's there. And Harmony Core does that extensively. So we provide definitions for partial methods in lots of different places, and you just have to write the partial class and put the partial method implementation in there, and we will then call it for you at certain times. So that's a very useful technique for dealing with, customizing generated code also.
And then we'll allow one more question because I want to let people mosey on to Marty Lewis's presentation after this. Tim is asking about referencing other templates from within a template.
You can, template, there is an include mechanism. So if you want to include one piece of template code into multiple others, there is an include syntax. You can also, there are file header tokens that allow you to specify to CodeGen that if I generate from this template, then you should also process this one, this one, this one, and this one. So you can process a single template with CodeGen, and it fires off the generation from multiple others. So you might have one command that produces 5 output files, for example. So yes.